Assistant Professor, Department of Mathematics in SNS College of Technology. Today we are going to solve one problem based on diagonalization. So in this previous class we have discussed in the methods of diagonalization and applications of the diagonalization. So in this class we are going to solve the problem based on the diagonalization. Here we are going to see reduce this matrix. So in this matrix to diagonal form. So given matrix we are going to reduce the diagonal form using the orthogonal transformation. So in this diagonalization we are going to solve the following steps. First we are going to solve what is characteristic equation and eigenvalue and eigenvector. So in this problem is a 3 by 3 matrix. So it is a 3 cross 3 matrix. So we are going to solve the 3 eigenvalues using the characteristic equation. In this characteristic equation is lambda cube minus c1 lambda square that is minus c1 lambda square plus c2 lambda minus c3 equal to 0. First we are going to start the positive and then negative, alternatively positive, negative equal to 0. Here we want to use and solve the C1 and C2, C3. C1 is nothing but the, what is the sum of the main diagonal elements. So adding all the diagonal elements, that is 1 plus 3 plus 3, that is 7. Next, how we can find C2? C2 is nothing but sum of the minor of the main diagonal element. Sum of the minor of the main diagonal element is we leaving the first row and first column. So then we have to determine. So 3 into 3 is 9. Minus into minus is plus. The formula having minus. So that minus is minus 1. So 9 minus 1 is 8. Then we are going to leave the second row and second column, that is 3 minus 0. Plus we are going to leave the third row and third column. So 1 0 0 3. That is 3. So after simplification we get 8 plus 3 plus 3 is 14. This is the C2. Next we are going to see how we can find the C3. C3 is nothing but the determinant of A. In this determinant of A, first we are using plus term and then minus and then plus. Okay. So here we including 1. So I am writing 1. Next, the remaining is we are going to simplify using the determinant. So in this determinant is already solved. That is 8. So we put 8. Next, 0 into anything is 0. So we put 0. And also 0 is 0. So here C3 value is 8. So then we have to substitute C1, C2, C3 here. So 7 lambda square plus 14 lambda minus 8 equal to 0. Here solving these equation in the calculator, we get the eigenvalues are 1, 2, 4. So it is a 3 by 3 matrix. So the eigenvalues are 1, 2, 4. Okay. So we are going to check using the property also. Here what is the property? Yes, first property is sum of diagonal elements equal to what is that? Sum of eigenvalue. Sum of eigenvalue. Here we are adding the eigenvalue. 1 plus 2 is 3. 3 plus 4 is 7. Sum of diagonal element is 7. So it is correct. Using the second property also, product of eigenvalue is equal to determinant of A. So product of eigenvalue, using the product of eigenvalue, 1 into 2 into 4, that is 1 into 2 is 2, 2 into 4 is 8. So our determinant is 8. So the eigenvalue is correct. So in this problem, the eigenvalue is 1, 2, 4. Using the eigenvalue, we are going to solve the eigenvector. So in this eigenvector is A minus lambda I into x equal to 0. So in this A minus lambda into I is, we are going to subtract the diagonal in this minus lambda, x1, x2, x3 equal to 0. So in this matrix, first eigenvalue is, what is the first eigenvalue is lambda is 1. So here that is first eigenvalue is 1 minus lambda into 0. Okay. So here we are going to subtracting that is 1 minus 1, that is the value is 0. Again 3 minus lambda is 0, that is 3 minus 1 is 2. 0, 0 minus 1, 3 here 3 minus 1 is 2. Okay, x1, x2, x3 equal to 0. So here see the three equations are same or different. Here the three equations are different, but the first row is all the elements are 0. So no need to consider this row. If it is considered, the eigenvector is fully 0, 0, 0. If you know, eigenvector is a non-zero vector, so no need to consider this row. So we are going to consider this two rows. Here x1, x2, x3. Using the cross multiplication. Here we want to start 2 minus 1, minus 1, 2. Here also 0, 0, 2, minus 1. So here then we are going to take the determinant form. So 4 minus here minus 1 into minus 1 is plus 1. Formula having minus. Here also 0, 0, 0, 0. Okay. So after simplification we get 3, 0, 0. Again if you want to simplify 3. That is 3 divided by 3 is 1, 0 divided by 3, 0 divided by 3, that is 1, 0, 0. Similarly, we are going to solve second eigenvector. So in the second eigenvector, we are going to using the second eigenvalue. In the second eigenvalue, our eigenvalue is 1, 2, 4. So here we are going to subtract 2. Okay, so this matrix minus 1, 0, 0, 0, 1 minus 0 minus 1, 1, x1, x2, x3. So see, all the equations are same or different. What is it? The two equations are same. That is, second and third equations are same. So here in the second row, we are going to take minus outside. So that is 0, minus 1, plus 1. See the third, it is same. Okay, so the second and third are same. So we are going to using in the same, we are going to consider one equation. So here we want to using the first and second row. So here similarly we are going to using this text. So 0, 1, 0, that is 0, minus 1, minus 1, 0, 0, 1. Then taking the determinant, we get the x equal to 0, minus 1, 1. So similarly we are going to use case 3, that is lambda equal to 4. So similarly using these steps, we are getting the third eigenvector is, that is the third eigenvector is 0, minus 1, 1. Okay, so these are the three eigenvectors. In this next class, we are going to continue this problem and then reduce the diagonal matrix.